Alright, now that we are experts at graphing linear inequalities, we are going to take it one step further and start graphing systems of linear inequalities, which just means we're going to graph two of them on the same coordinate plane. Just like graphing systems of equations, we have to graph the two lines. The major difference now is we have to shade, and we're going to see that's challenging enough when it's just one equation or one inequality. It gets a little bit even more challenging with two, so kind of bear with me for a couple of examples here on the front. We'll do one different type of example on the back and then just kind of ease out of the video with a couple of quick ideas as to what is or is not a solution. In this first example, we do see our equation is in slope-intercept form, so we can pick out our slope of 2/3 and our y-intercept of 0, -8. The symbol, being a greater than symbol, means it's going to be a dashed line, and generally we believe we will be shading because it's in slope-intercept form and it's greater than, we will shade above. So when I graph this, 0, -8 is where I begin. +2 over +3, +2 in my numerator is up, +3 in my denominator is right, up and right, up and right. But I have this pattern going backwards, down, left, down, left, down, left. I can go down and left 3 as well. Now to this. It is a greater than symbol, that is a dashed line, so I'm going through here with my straight edge and graphing a dashed line. And generally I'm going to shade above. I don't want to actually shade this in yet, because at the end of the day I'm going to have to pick where to shade based on the intersection. That will become more clear, but for now what I want us to do is just make a little note kind of that we are going to shade this above. I like to go to the ends. This is why at the very beginning of the year when we started graphing I said graph all the way through your coordinate plane. Don't stop somewhere in the middle. I'm going to go over to here and make sure I'm above, dropping the water. This is the top, this is above, that's where I have to shade. I'm just going to put a little A here. But I'm going to go to the other end and put a little A here as well. It's a capital A written small. That's just indicating that that's the side of this line that I would shade if it were on its own. Now, let's graph our second inequality. Slope-intercept form. I have a slope of -3, which is -3 over 1. A y-intercept of 0, 7. It's a less than or equal to symbol. That means it's going to be a solid line, which does matter. And because it's less than, I will likely shade this below. 0, 7, -3 in the top means go down 3, +1 in the denominator means right 1, down 3, 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 right 1, no more, so I could go up, left, up, left, up, left, up, left, up, left, and I can fit one more here. And again, I go back and I look, it's a solid line. So with my straight edge, I graph that solid line and I put arrows. My line has gone all the way through. This time, I'm supposed to shade below. So again, think about going above at the very top, dropping a little bit of water. That's hitting above. The water, when you drop something from the top, it hits above your line. I don't want to shade there. So I'm going to go to the other side. This would be considered below my line. This is the side that I'm going to shade on that solid line all the way over here, and then here still below is on this side because water would drop on top. Now I'm looking at these four things because where do I shade? Well, it was below this line and above this line. We want to shade where those intersect. Okay. So generally, don't copy this yet, but below this line means I would have shaded all of this. Above my dashed line means I would have shaded all of this. Well, that's really confusing. So we don't want to graph things that way. We want to just shade one section. So to figure that section out, we look at where we put this B or this A. Okay? Since this B and this A are both in this section, we have 4 sections. 1, 2, 3, 4. That's the only section that has both. Means I shade below that line and above this line. This section 1 is where all of that overlaps. Sure, I shade in this section for this line, but not for this line. It has to work in both. It doesn't work for my solid line. This doesn't work for either. This works for my solid line, but not my dashed line. So when I shade this section, or this graph, I need to be very careful. I shade it only in section 1 here. Now, you're not going to name it section 1. We're not going to write section 1. We just have to recognize that it is section 1. Okay. Now I can look and analyze it a little bit. Is -1, -2 a solution? Well, -1 in x, -2 in y is this point. I don't have to plug it in anywhere. I know it's a solution because it's in the area that is shaded, that matches or solves both inequalities. So I can state right away, yes, it is in the shaded region. When I check a different point, like 4, 1, is that a solution? No, not at all. It's not in my shaded region. And that's what we would put as our answer. Let's do another example together. Again, this one's already in slope-intercept form. So in my first inequality, y is greater than or equal to -1/3 x minus 4. I know my slope is -1/3. My y-intercept is 0, -4. This symbol with the line under it tells me it's going to be a solid line. Spell that correct. And because it's greater than, I will likely shade above. So -4, -1/3 is my slope, means down 1, right 3. And through the magic of video, we have our whole line. Now above, this one's a little easier because it's a relatively flat line. This is the above, so I'm going to go above here, I'm going to go above here, and move to my second inequality. Y is greater than 5x minus 4. Go ahead, pause, and try to graph that line. So we should see these have the same y-intercept at -4, but this slope of 5/1 means it's pretty close to vertical. It's a dashed line because of the symbol. I will shade above this one as well. So above, I go to the top and I drop a little bit of water. It's hitting the top, that's above. That's where I'm going to shade here. I drop it and I hit above here. So now I have 4 regions. Region 1, 2, 3, and 4. The region that has both areas that being shaded is the region I shade. Okay, region 1 has an A and an A. That's good. That's what I'm looking for. That's what I'll shade. Now you'll see me now start to shade in videos just using the highlighter. I know I'm shading above this line. I'm shading above this line. This is the region that gets shaded in then. In my other regions, I might have one but not both. Example, I shade above here, but I don't shade this side of that line. I can't shade that whole region. And I shade above here, but I'm not shading on this side of the line. I can't shade that region. In this region, I'm not shading anything. That's the only part that's a solution. So now, any one of these ordered pairs, anything over here is a solution to my inequalities, or my system. Anything over here is not. All of these are solutions. And these are not, and not. on the back, example 3, this one is more challenging for the sheer fact that they're not in slope-intercept form yet. So I would have to start by solving for y. 4x plus 16. Go through the process of solving for y. Divide everything by 2. Y is less than 2x plus 8. So that's one inequality I'll have to graph. I also have negative 4x plus 3y is greater than negative 3. Solve for y. Add 4x, add 4x. 3y is greater than, my 4x is positive, minus 3. Divide everything by 3. My second inequality becomes y is greater than 4/3 x minus 1. So your job is to press pause and try to graph that system of inequalities. So maybe you got to this point where you see, that's an above, where you see that you have a slope of 4/3, 0, negative 1, start, up 4, right 3, and it's a dashed line shade above. This one had 0, 8 as your starting point, up 2, right 1, or down 2, left 1. It's dashed and below. We don't have 4 sections now, we have 3. That's okay. Is there an overlap? We should see that yes there is, because I'm shading below, all below that first line or that top line, but I'm shading all above this line. That's an overlap. That's where I'm going to shade, in between my two inequalities. This is the section that gets shaded in, everything in between. We'll do a lot more practice of this in class. But before we get there, let's talk about our last problem here. And this is what it's going to look like on some of your tests and quizzes. So what I've represented here is I have a dashed line that's being shaded below. Since this is lightly shaded, heavily shaded, lightly shaded, what I'm saying is the dashed line is being shaded everywhere below. The solid line is being shaded everywhere above. This is really dark shading, because that's where the two overlap. So the green on my screen now is a solution to the dashed line. The blue is a solution to the blue line. The overlap is a solution to both, or the solution to that solid line. The overlap is the solution to both. So when I'm asking questions like, is the point a solution, I'm asking, is it in my dark shaded region? That's all I'm really looking for. So the 0.78 means go to 7 on your x, 8 on your y. Is it a solution to the system graphed? No, it's not, because the only solutions are in here, in that dark region. So 7, negative 8, not a solution. 0, 4, this one's tricky. 0, 4 is right on that dashed line, overlapping my dark area. So part of us would say yes and part of us would say no. And the part that says no is correct. Now this one's tricky. It's a no because the line it's on is dashed. So think about that like our number line. If I were shading in a number line, this is not a solution, but all of this is. That's what I'm saying here. Anything on this line is not a solution, but below it is. So because it's on a dashed line, it's not a solution. Negative 7, negative 4, however, that's a yes. And that one's a little confusing. It's the same idea, but this is on a solid line. That's like it's saying, hey, this is a solution, and so is this. That's a yes. So is a point on the solid line, as long as it's also adjacent to our shaded region. Example, this point here would be a no. That would be a no. It's on the solid line, but not by my shaded region. So on solid line, and